Hi guys, welcome to lesson 5.7, scatter plots and trend lines. This is your final lesson in chapter 5. Our objective for today is that I can create and analyze scatter plots. So we've got a whole bunch of new vocabulary to introduce. A scatter plot is a graph that relates two different sets of data, displaying them as ordered pairs. Correlation, or sometimes talked about as association, is the trend in the relationship between the two variables. One thing that I like to put in here is causation, when a change in one quantity causes a change in the other. Clustering is groupings of data points tightly packed on a graph. And outliers are data points that are outside most of the values in a data set, so you'll be able to see them on a graph. Our essential understanding is that you can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line to estimate or predict their values. So the first thing we're going to do is we are going to read these scatter plots. Now, the first question says, in the scatter plot to the left, what does the ordered pair 150 and 1,500 represent? So 150 is our x-axis, which is tickets sold. We have 150 tickets sold. And our 1,500 is our y value, which is the amount of money collected. So we have $1,500 collected. So in the scatter plot to the left, what does 350 and 2,100 represent? Well, 350 again is 350 tickets. And the 2,100 is $2,100 collected. So we're just looking to see what are the units of my axes. Now, how many tickets were sold when the amount of money collected was $2,700? So if we looked at our graph and we move our way over from $2,700, here's a point that we have on our graph. So that is one day when we collected $2,700. And to do that, we sold 450 tickets. All right. Moving on to the next section, making scatter plots. So at the top of your page there, you have a list of values. We have the age in years of a car and the value in dollars of that car. What is the car worth? The average value of a midsize sedan. So the first row of points I have already graphed on the grid at the bottom for you because you know how to graph some of them. So those are the ones that are in purple. Now I'm going to put in blue the bottom row of points. So we have a point at, for the record, my scales. I have a scale of 5, 10, 15, and 20 years on my x-axis. My values are going to go up by 1,000 per line. I only marked the bold ones. So it is $5,000, $10,000, $15,000, and $20,000. So now I'm going to go ahead and fill in the last 5 of my points. So I have a point at 1 year and $15,000. I have a point at 4 years and $8,000. I have a point at 5 years and $7,000. I have a point at 3 years and $6,000. And I have a point at 6 years and $6,000. All right, so that is a table that shows us the average value of a car compared with its years. Now, remember I said that term causation. Does the age of a car cause its value to go down? And for the vast majority of cars, it does. Now, if you're talking about some classic cars and some of those rare cars, the value would go up as they get older. But there's more than correlation here, there's causation. As the car gets older, it is worth less money. All right. Our next section here is going to be about identifying clustering and outliers. And again, I've already graphed part of the data points for you. So if you want to pause the video and catch up to what I have here, go ahead. I've labeled my x-axis as the age in years of the tree. And I went up by ones. I only wrote the odd numbers though. My y-axis is the height in feet of the tree. And I went up by 10-foot intervals. Now I've already got these first ones graphed, and you'll notice some of them are pretty close together, 5 and 42 feet, 43 feet, and 45 feet. So you're just going to have to kind of put a couple points close together on those. All right, so now if we go into the rest of our points, we've got a point at 7 and 98 feet, so that'll be right about here. We have a point at 3 and 39. Right about there. We have a point at 4 and 44, so that's right about there. 3 and 46, so that'll be about there. 5 and 38. And 6 and 49. So now that I've got all of my data kind of shown there, I need to answer my questions down below. Now the first question is, identify any clustering in the data, and if there is, describe it. So I definitely see there's a pretty good sized cluster right there. So I would say between 3 and 7 years, there's a cluster, and it's also between 35 and 50 feet. Okay. So now if I'm looking for outliers, remember I said those are data points that are set well away from the group. That one right there is definitely an outlier, and I would say that one right there probably is as well. All right, so we have a point, those are the points for 12, so a tree that is 4 years old, but it's only 12 feet tall. And you have a tree that is 7 years old and 98 feet tall, which is pretty large. If any of you have been out to California and seen the sequoias or the redwoods, tall trees are pretty impressive. All right. Describe associations in scatter plots. So we are going to describe what we're seeing here. Now, on the top, our first section is asking us to identify whether they are positive, negative, or no association. So negative, this first one is going to be negative. You can see as we go left to right across the graph, the data points look to be going down. So it's going to be a negative association. Now, in the middle graph here, it looks like the trend seems to be going up as we go from left to right. So that's going to be a positive association or correlation. And if it just kind of looks like chicken pox, no association. All right, and we could also use the word correlation. Now, this is where I do kind of want to talk about the idea of causation and correlation. Just because data is following a pattern, it does not necessarily mean that one of the variables is determining the outcome of the other. It's not necessarily that one is an independent and one is a dependent variable. They just may have a relationship together that this is the way the pattern shows, but it's not that one is causing the other. All right, that's the idea between causation. Okay. Bottom half of the page, we want to identify whether they are linear or nonlinear associations. So the first one, we see the points are clustered pretty tightly in kind of a little band there. So that would be a linear association or correlation. In number 7 here, it looks like there's kind of a bell curve going on here. And so that is clearly not a straight line, so that's going to be non-linear. All right. Moving on to the next page. We are going to make a scatter plot using the data in the table and then answer some questions. So I, again, have already graphed some of these points for you guys. So we have hours spent studying on the x-axis. We have grade earned on the y-axis. And I'm going by half-hour increments for the x, and I'm going by 10% for the y. So I've graphed the first handful of points. I'm going to put up the last couple. So we have a point at 2 hours and 85%. I have a point at 4 hours and 96%. 3 hours and 98%. And 2 hours and 88%. And you can see we had a couple other points here, particularly this 0 hours is 0 hours and 71%. Not so good. Although kind of some of you probably wish you would get a 71% if you studied no hours. So, describe the pattern of association that the scatter plot shows. First of all, let's just kind of look at it in general terms. It seems like we have a line that's going up. So I would say that is a positive association. I would also say that they are clustered pretty closely on a line. So I would say it's linear. So that is a positive linear association. Okay. All right. Next up, we have drawing trend lines. Now, when we draw trend lines, the first step is going to be to plot our data points. Our second step is going to be to identify if the plotted points form a positive or negative linear association. And then we're going to try to draw a line so that we have about as many points above and below the line. And then we're going to use that to make predictions. Okay, so I didn't put any of our data in yet. I figured we'd do this all at once. So we have a tree that is 19 feet high, and it has a circumference of 10, so it could be right there. 32 and 63, so something like that. 57 and 72. It'll be somewhere around there. 43 and 111. So we have 43, 111. It's going to be something like that. 75 and 150. 97 and 185. And 110 and 214. All right, so now we're going to use a straight edge, and we're going to try to find a place where we can put a line that we're going to have about the same number of points on each side. So if I go through a couple of these, if I have a line about like this, I have 3 points above and 2 points below, and I have 2 points just on the line. So I think that's actually pretty good right there. So we're going to draw a line something like this. All right, so we got a couple points on, so we got 2 above, 2 below, and one of them turned out to be actually closer to the line than I thought it was. All right, so that's a rough approximation of a trend line to fit the data. So now we want to answer the question at the bottom here, which is, a tree with a circumference of 175 inches should have a height of about, well, if we have a tree with a circumference of 175, so it'll be right about there. We find where it is on our graph, work our way down, and it's between 90 and 100. So let's say 95 feet. These are approximation, guys. They are not going to be perfect answers, and you might be a little different than your neighbor depending on where you put your trend line. How closely you put it to one point or another is going to affect your outcome. But it should be, these are going to be answers that need to be done within a certain margin of error. All right, title for the next section ended up on this page, Assessing the Fit of Trend Lines. So our question is to determine which trend line appears to be the best fit, the one on the left or the one on the right. Well, when I look at the one on the left, I have 2 points that are going right through it, but I have 1, 2, 3, 4, 5, 6 points below it. So that line doesn't really represent the center of this data set. I would say the second one is a much better fit because we've got 1, 2, 3, 4 data points above and 4 data points below. So that trend line looks like it's going right down the middle of those data points. So that's a good one. All right. Next up, using an equation of a trend line. So we would be able to make a scatter plot and draw a trend line and identify 2 coordinates, use them to find the slope, find the y-intercept, and then substitute and so on. We're not going to write the equations quite as much because I just don't want to. So we're going to start off, and I did not prep this one. So we have age in months on our x-axis. We've got our weight in pounds on our y-axis. I'm going to go by ones on my x. And I'm going to go by tens on my y, only writing the odd numbers. All right, now I need to graph my points. So I have a point at 0 and 0.8, so that'll be right about there. When the puppy is born, it has 0.8 of a pound of weight. We have a point at 1 and 9.2, so just under 10. We have a point at 2 and 19.9. We have a point at 3 and 31, so just over 30. We have a point at 4 and 41, so just over 40. 5 and 50.6, so just above 50. 6 and 57.4. 7 and 62.6, so our rate of growth is slowing down a little bit. 8 and 66.4. So we've got a linear equation, and now we need to go ahead and draw a graph. So I'm going to use my y-intercept that we already know as one of my points. And I need to figure out what do I want to do with my graph from there. So if I'm moving my line in, I have 1 point covered, 2 points covered, 3 points covered, 4 above. So maybe if I go through that 4th point, so maybe that was a little on the high side, but that's all right. We can use that trend line. Well, I do need to extend it to the end of my graph. There we go. All right. So now the bottom of the page is asking us to find about how much a 10-month-old puppy is going to weigh. So if I find 10 on my x-axis, 10-month-old puppy, follow it up to my grid, or to my line, and work my way across, I'm going to say that that puppy should probably be about, I don't know, maybe 92 pounds. So is that a perfect prediction? Because as we see in our data, it seems like it's kind of, we had some big growth at the beginning, then it's kind of tapering off a little bit. So it's linear, but there's some iffiness to it. All right, now if you drew your line a little shallower, if you maybe went through some of these points instead, your value of your puppy might be in the 80s if you went a little shallower with the line. All right, so there's a little bit of variation that can be expected in scatter plots and making predictions. All right, that's the end of this lesson. Sorry it was a long one. We had to get through a bunch of stuff. So rate your level of understanding on scatter plots. Write down any questions that you may have come up with while I was talking, and then do go ahead and fill in your summary of what this lesson was all about. And I will see you guys in class later.